block of mass 6 kilograms has an initial speed of 2 meters per second and is projected down a rough plane inclined at 60 degrees to the horizontal. The frictional force is a constant 4 newtons. Find the speed of the block after it has travelled 9 meters down the plane. So here we've got a block, we've got a frictional force acting 4 newtons up the plane. The block is going to travel through 9 meters and has an initial speed of 2 meters per second. And we want to find the final velocity. So the potential energy would be, we have to find this height here. However, first of all, we need to consider this. This is what's known as an example of a non-conservative system, as not all of the potential energy is going to be converted to kinetic energy. Some of the energy is lost for the work done to overcome this frictional force here. And we're also going to ignore air resistance in this problem. So what we need to do is first of all calculate the initial potential energy that is going to be lost when it goes down this height. Now this height here, this vertical height lost by the body is given by h, and therefore h will be 9, because it's this length here, 9, sine of the angle here, 60 degrees. Sine of 60 is root 3 over 2, so we're just going to leave it as 9 root 3 over 2 meters to begin with. It's always better to deal with the surds right at the end of the calculation. Right, so the potential energy loss when travelling down this plane is going to be mgh. So it's going to be 6 times 9.8 times 9 times root 3 over 2, and that is 264.6 root 3 joules. Now, as the block has an initial velocity, then it already has some kinetic energy. So the kinetic energy gained will be a half mv squared minus a half mu squared. And obviously we've got to calculate v. So that's going to be a half of times the mass of the block, which is 6 times v squared, minus a half times 6 times 2 squared. So that gives me half of 6 is 3, so that's 3v squared. Half of 6 is 3, and 3 times 4 gives me 12. So this will be the kinetic energy gained when this block goes down this plane here. So this has to be equal to this. However, there's also some work done to overcome this frictional force here. So the work done by the frictional force is equal to the force times the displacement. This force moves down a distance of 9 meters, and it's a constant force. So it's going to be 4 times 9, which is 36 joules. So the potential energy, so by the conservation of energy now, the potential energy lost is converted into kinetic energy and the work done in order to overcome the force. So this potential energy loss has to be equal to this plus this. So the potential energy is equal to the kinetic energy gained plus the work done. So it's going to be 264.6 root 3, because that's the potential energy lost, is equal to the kinetic energy gained, which is 3v squared minus 12, plus the work done, which is 36. Rearranging that, we're going to get that v squared is 264.6 root 3, minus 12 plus 36 is 24. When we take it over here, it becomes minus 24 divided by 3. So v squared will be 144.420 on my calculator. To find v, I need to take the square root of that. I get 12.01 meters per second. And therefore, the final answer to this will be the final velocity when it goes through this 9 meters will be 12 meters per second, correct to 3 significant figures. Okay, so this is an example of a non-conservative system where the sum of the potential energy is actually converted, is used to overcome the frictional force.